Welcome back to Mind Over Math. In our previous lesson, we learned about limits, which are the foundation of calculus. Today, we're taking the next big step, learning what a derivative really is and how it's calculated from first principles. By the end of this lesson, you'll know what a derivative represents, the first principles formula, how to calculate derivatives step by step, and why derivatives matter in science, engineering, economics, and everyday life. Let's get started. Part 1. What is a derivative? Imagine driving a car. Your speed changes every second. A derivative tells us how fast something is changing at one exact moment. Examples include the speed of a moving car, growth of a population, change in temperature, and business profit over time. A derivative measures the instantaneous rate of change. Part 2. The first principles formula. The derivative is defined by f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. In this formula, f of x plus h is the new function value. F of x is the original value, h is a tiny change in x, and the limit makes that change approach 0. This formula is the definition of every derivative you'll learn. Part 3. Example 1. Find the derivative of f of x equals x squared. Step 1. Compute f of x plus h. That gives us x plus h squared. Expand it to get x squared plus 2xh plus h squared. Subtract f of x to get 2xh plus h squared. Divide by h to get 2x plus h. Now take the limit as h approaches 0 to get 2x. So the final answer is f prime of x equals 2x. Part 4. Example 2. Find the derivative of f of x equals 3x plus 5. Substitute into the first principles formula, simplify, and everything cancels except 3. So the derivative is 3. This shows that every linear function has a derivative equal to its slope. Part 5. Graph interpretation. A derivative represents the slope of the tangent line. If the graph goes upward, the derivative is positive. If the graph goes downward, the derivative is negative. If the graph is flat, the derivative equals 0. Part 6. Common mistakes. Avoid these errors, forgetting to expand x plus h squared, canceling terms incorrectly, forgetting to divide every term by h, and skipping the limit step. Take your time and simplify carefully. Part 7. Why this matters. Every derivative rule you learn later comes from first principles. The power rule, product rule, quotient rule, and chain rule are all shortcuts based on this definition. If you understand first principles, advanced calculus becomes much easier. Today you learned what a derivative is, the first principles formula, how to calculate derivatives from scratch, and why derivatives are important. In the next lesson, we'll learn the power rule, the fastest way to find derivatives without using first principles every time. Thanks for watching Mind Over Math, and I'll see you in the next calculus lesson.